All right, so this PowerPoint just jumps right into it. No preparatory text, no, this is the history of programming and hardware as a computer and, and output as a printer and, stuff like that. Just jumps right into the language. And that's cool. You get kind of tired of seeing the history of computers in every computer book you buy. All right. So things that we type in to our program. Whoops, didn't mean to launch it like that. I'm going to do it as Notepad. Are called tokens. For example, float, int, if, while, else. All those words are tokens. As well as things like 1, 2, 3, Tony Stark, etc. Those are also tokens. Everything we type in is called a token. I'm only mentioning that because it's right here. Probably won't use the phrase again. More tokens. And then there are these are called keywords or reserved words. We will call them keywords. So we will call these keyword tokens or just keywords from now on. And these are known as constants or literals. There's other ways. Because they're constant values of 123, right? Somebody's name, right? Okay. And then lastly, there are what are known as identifiers. Those are like variable names, age, name, and function names, like, print results. All of those are called identifiers. Variable names, functions. Okay, so now we've seen 3 different kinds of tokens. I'm going to remove the word tokens because usually you just say that these are called keywords, that these are called constants or literals. Why? Because it's literally typed into the code. If we say, name equals Tony Stark inside the file, and then later on Peter Parker wanted to use the program, we'd actually have to find the .c file and edit it in order to, make it say Peter Parker, right? It's hard-coded into the program. It's literally typed into the program. Yeah. So if it's a number or if it's a string, surrounded by double quotes, or if it's a single letter surrounded by single quotes, in Python there was no difference between double quotes and single quotes. In this language there is. This is called a string, and this is called a character. You use single quotes around a character. You use double quotes around a string. Single quotes for characters. Example, like that. All of those are characters. Anything you can type in on the keyboard, right? And then double quotes for strings. What is a string? It's a series of characters. Although it could even be 0 characters in length, right? But it's still a string. Like, hello, right? Tony, whatever, like that. All right, so we may have to add this to our programs, and last semester I found out that that's the truth, in order to get some things to compile. So we're just going to wind up copying and pasting that into our code. You don't even need to know what it means, but it means that there's a specific error that can be generated because C++ is a more modern compiler than C, and it tries to catch some errors in C that we don't mind actually making. Or risky behavior, I shouldn't call it them errors, just because C came before C++. But we can tell the C++ compiler, no, this is okay. This is okay practice, right? Like in old days, you could, play football without a helmet. Nowadays, you do have to wear a helmet. But this would be saying, nah, it's okay to play the football without the helmet. All right, I'm going to skip preprocessor. We will come back to it. Wow, there sure is a lot about preprocessor. We will. Okay, that's an awful lot about preprocessors. Really? All right. So there are string literals, which is something with quotes around it. And then there are operators. Operators are the symbols, like the addition symbol and the subtraction symbol, multiplication symbol. And this language, instead of using the words and, or, use special symbols for and or. So those are all operators. Those are another form of token. I'm going to go back and add them up here to our kinds of tokens. Maybe I should, kinds of tokens. And even number them, enumerate them, so that we can tell what they are. Right, just so we can make sense out of them. Or I guess I could just put asterisk in front of them. And then the fourth kind is operators, like plus and minus and plus plus and equal sign and double equals and all the symbols. Those are all tokens. 4 different kinds of tokens. Hopefully I'll stop using the word tokens. I don't like it. What I most care about are the keywords, the variable names, and the operators. Those are the terms that we're going to be using a lot. And then there's Whitespace. I don't recall if I mentioned this, but Whitespace is just for convenience. It's not necessary. Or it's not, there's no strict rules like there's in Python. In Python, you had to hit the tab key and you had to line up everything. In this language, instead, you use curly braces, and then after that, you don't have to tab up everything. It's good practice, right? Makes you kind of look like a slob if you don't line up everything with tabs, but it'll work. You could put almost an entire program on one line of code. Can I write that? So basic data types. Just like in Python, there are integers, which are whole numbers. And then there are floats, which are floating point numbers. Now, even if they look like they're the same thing, they're not. And what do I mean by that? If you say something is equal to 2, and then you say something else is equal to 2.0, so data types. We have ints, which are whole numbers. Not whole with, yeah, let's spell that correctly, whole numbers. And then we have floats, which are floating point numbers with a decimal point. These are stored in completely different formats in the computer. So as far as the computer is concerned, a 2 is very different from a 2.0. And there are times when we care about that we care about the difference. There are other times when we don't care about the difference, but we just kind of need to keep in the back of our head that whole numbers and floating point numbers are different things. They are actually stored in the computer as very different things. Why? Well, because an integer is just a whole number, right? It doesn't have a fractional part. And if you took chemistry or something like that, you're probably used to seeing, numbers like this, 6.00 e to the 23. Well, that's a floating point number, right? This is a fractional component, and this is an exponent. A floating point data format needs to be able to handle all that, and an integer doesn't. So they are very different from each other. So examples of whole numbers, 2, 0, negative 999, right? And then examples of floating point numbers, 3.14159, comma 2.0, comma 0.0, comma 0.000, right? Those are all floating point numbers. Notice that even though these look like, to our brains, they're the same thing, they're not. Now I'll give you an example of how the computer could wind up treating these as different things. If you say print 3 divided by 2, it's actually going to print 1. And you say, what the heck? It's just gonna. But if you say print 3 divided by 2.0, it's going to print 1.5. Just the mere fact that this is a whole number made the computer's math behave differently than that. It rounded it down because it was an integer. Now, you don't have to worry about that yet. You don't have to burn that into your brain right now. It doesn't have to make sense right now. But if you divide two integers, two whole numbers, in the C and the C++ language, in Java, they get rounded down. And that wasn't true of Python. Python didn't round down. If you did 3 divided by 2 in Python, it equaled 1.5. Just like if you did 3 divided by 2.0, it equals 1.5. But I want things to work the same as Python. No, we just don't have that luck. If it worked the same as Python, it would be the Python language. Python was written long after some of these other languages, and so they tried to simplify certain things, like the fact that you can get rounding, numbers rounded down when you don't expect it. So integers are stored in various sizes. What does that mean? I could give you a big old long lecture about bits and bytes and integers. But suffice it to say that the more memory that is allocated to a variable, the larger the number that can be stored in it. Now that we know what a byte is, not that we know what a bit is, but maybe you do. A bit is a single digit that's either a 0 or a 1. Ultimately, that's all that computers can store, are zeros and ones. If you open up your hard drive and you took a microscope to it, you see a million zeros or ones. No, I'm kidding. You wouldn't see anything like that. But that's the way it works. It's like there's a million little switches. And not just a million, right? Billions of little switches in the computer's RAM that are either set to 0 or 1 and that they change, electronically upon, as needed to represent data. The more bits that are dedicated to your variable, the bigger the number that can be stored in it. So bits are grouped together in bytes. 8 bits equals a byte. There's something called an int, an integer type, which is 4 bytes. It can hold a pretty large number. And then there's something even longer, much larger, called a long. Now, I know that's a stupid term, but a long int is 8 bytes, which is 64. So, it has a lot more spaces in order to hold a number. Now, the limit for an integer is about 2 billion. It can hold numbers up, to about 2 billion for reasons I won't explain yet. A long can hold up numbers like in the quadrillions or whatever. And if you need a number larger than that, you use a double, which is a floating point type, because since floating point types can have exponents, right? 3 to the exponent of 669, that's a 3 followed by 6 9 zeros. It's huge. So the number of bytes dictate the size of data that can be stored in it. I'm going to kind of blow past this page for now because I don't feel like teaching all the count in binary at this point. We'll go back to it. If y'all had me in fundamentals of computer, then this would be a repeat lecture and you'd get bored. But hopefully you won't get bored. So there are floats, which are made out of 4 bytes. This is a floating point type. And a double is a double wide, which can store 8 bytes. A 4-byte number is about 6 decimal digits, it says. Yeah, I'll go with that. Right, really it can go up to 2 billion, not just 9999999, but yeah. And then the double wide float with 8 bytes can store a much larger number, like maybe up to 14 decimal places, right? Now this is just talking a lot without letting us enter any code. I'm getting bored of not getting to enter any code. So I'm going to launch Visual Studio. Just so we can start putting this stuff into practice. All right, so new project. I launched Visual Studio and I chose File, New Project. And this is C_lecture_B. The only reason I'm calling it C is because I also teach C++ in the same room. I don't care if you put the C underscore in front of it or not. So what did I do? I did File New, and then I chose Blank Project under C++ just because C can be compiled by C++. It's backwards compatible. Just like your PlayStation 3 might be able to play PlayStation 2 games or something like that. Now I need to add a source file. So I'm going to right click on here and do Add, New Item, C++ file, but I'm actually just going to call it CPP. So why don't I just call it lectureb.c. CPP stands for C++. But I'm going to try not to use any C++ features, so I'm just calling it .c. Will it work? This? Yeah, let's give that a shot and see if that will work. Alrighty, here we go. What are we going to do first? Well, we're just going to define a function. Int main, parentheses, close parentheses, semicolon, and not semicolon, curly brace, and then a closed curly brace at the bottom. And all it's going to do is say int age equals 32. It's not going to do anything else. The only reason I've written such a short little program is so that I can test it to make sure it will compile without errors, right? Just to make sure that what we have set right, because if you can't pour the concrete, you're not going to be able to build a house on it. So we're going to see if our foundation works here. Looks like it worked. Now it ran and then immediately closed, right? Not super duper duper useful yet, but it did compile. Everybody who's trying to follow along on your computer, and we'll get Visual Studio up in the program page. So you're going to choose C++, that little down arrow or something, empty project. Let's give it a better name than Project 1. Let's call it Lecture B or something like that. Oh, and one thing I should have shown y'all, and it's kind of a drag too late now. It puts it in a stupid directory. I would rather us choose browse and put it into a better directory. So you click browse and put it in your documents. Visual Studio directory would be happier. Now you can see documents. Yeah. I guess we're in it. Okay. So then go to Visual Studio and we're good. So when you make these things, what I recommend you do in the future is when you're making your new project, browse and go to Documents, Visual Studio. Just to make them easy to find. Y'all doing okay? Good, everybody who wants to be. Yeah. Oh, yeah. Did you get this from Groups or from someone else? I just got it off maybe they need to get from Drinks Park. I don't want to make you do that. Let's see if we can get it going without it, but if it doesn't work, okay. Whitespace name, parentheses and parentheses, and next line, everybody's. Let's just say as. They want to go to Spark and install Visual Studio 2017. Just because I don't know what this is, but if you can find the link where you downloaded this from and mail it to me, because I'd like to install it and try that one out too. Because it looks like it'll be faster, quicker to download than the one from DreamSpark. And by the way, who was having trouble getting DreamSpark to work? Oh, yeah, y'all didn't install this. Pardon me?
I've never heard of that before.
Okay, because when you install, we didn't talk about it, did we?
No.
Alrighty. Hey guys who are watching at home, sorry about the 10-minute pause. I forgot to hit pause. You know, I'll try to do that from now on. Okay, y'all are going to need to download Visual Studio in order to do your work. And the way you're going to download Visual Studio, I need to make a document for it if I have not already. Okay, there it is. When you go into Canvas and you click on Home or Modules and you scroll down, you shouldn't be seeing that instructor only, but whatever. There's Installing Visual Studio. This is a C++ development environment, but it's actually for a whole bunch of different languages and not just C++. And our C programs do work under C++, so we're going to want that. So we're going to choose that, and then you'll want to have a C++ compiler. Apparently there are some free versions of Visual Studio out there, or we can get them from DreamSpark. Now that ought to be a clickable link, but it doesn't seem to be a clickable link, so I may just type in dreamspark.rose.edu or copy and paste. Now you're not going to do this on your school computer, but you could at least start the process if you feel like it. Control T to make a new page, whatever, dreamspark.rose.edu. And I'd like everybody here to go ahead and do that. And then click Sign In. And click Register. And I expect that since y'all aren't talking like you've heard of this before, that you didn't get any email about it. So I'm going to put in my rater.rose.edu address. I want one of y'all to try that as well. What is this? That sounds good to me. I'm going to click request an account and see what it does. Well, that's a whole bunch of information. I'd rather not have to go to that much trouble, but why not? Jeffrey Thompson, email, JG Thompson. You saw how I got to that, right? I went to the login, or I went to the sign in, and then I went to the register option. And then I clicked request an account. Y'all may not have to do this. We're going to find out real soon. I'm going to type in my first name, my last name, my email at rater.rose, my phone number, why not? You just go to Arlene Hayes in our department. Issue description. Trying to show students how to create their DreamSpark accounts. And in fact, I am not a robot. Click send. All right, your support request has been submitted. They will contact you directly. So that sort of worked. But if somebody hasn't done that yet, let me pause the recording. All right, so there's some questions that some students in the class have just been able to go to register, type in their email address, and it's all ready to go. Others type in their email address and it gives them an error, and so I told them to do request an account, but that has to be validated by an employee here. So if it doesn't work immediately, if it doesn't say that email was sent to you, then be patient and see what happens. So I guess the due date for actually installing Visual Studio at home is going to have to be Thursday rather than Tuesday, because I'm going to want to make sure that everybody has time to get their account ready and to download it. Okay, so back to where we were. If you didn't get this part done, then what you're going to want to do, I'm going to close this solution, is do File, New Project. Go ahead and do that part.
Oh, I'm in the source file window. I didn't know what name to give it.
Oh, okay. And so once you do that project, then you're going to want to go over here, right click on source files and do add new item and give it a cute name like lecture B. Except I'm going to call mine C lecture B, .c rather than .cpp. And click add, and it should create it there. Now I'm going to delete it because I don't need that one. You're not going to delete it. And then type in this. What we're really going to want to do is to make boilerplate that we can copy and paste into our programs every time. We'll get to the point where we want to do that. But we are going to want to add a # include at the top so that we can print something. This is called a preprocessor directive, or a preprocessor command. So # include angle IO that's looking different. I want you to look exactly like we're going to see in our code. Just a second. Get the example out of our PowerPoint. Here we go. We want stdio.h. Okay, so I goofed that one up. Angle stdio.h. I started to type in a C++ library instead, and I don't want us to be using C++ features. I'm going to try to assiduously avoid them. Now the reason we did that is so we could use what's known as a printf command, like this. Printf, parentheses, quote, my age is %d. Well, what's that %d? Well, I'll tell you in a minute. And I'm going to add a space there even though it's not necessary. /n, \n, the one up next to the enter key, the one above the enter key. And after that, %d, comma, age. And after that, parentheses, a semicolon. You can tell that this looks a little bit more arcane than Python, but you can get the idea pretty fast. First time you see it, not. Second time you see it, yeah. All right, but it's closing the window. And if it is closing the window as soon as it runs, then we need to find a way of keeping the window open. Now, this isn't a problem for the Mac users using Xcode, but for the Windows users using Visual Studio, it is. So we're going to add a command, if we're using Windows, called pause. So I'm going to type system, parentheses, quote, pause, end quote, in parentheses, semicolon. Now what does that do? Well, if you were sitting here at the command prompt, what people used to call the DOS prompt, and you typed in pause, it would press any key to continue. Well, that's what this is going to do too. It's going to print my age is, and then it's going to do press any key to continue. So it's just going to leave the program open so that we can see the results. All right, my age is 32. Press any key to continue. Let's see.
I got this up.
And it's complaining that it doesn't know where that is. I don't know how to fix that because I've never used the free version of Visual Studio. I really ought to learn. What I strongly recommend doing is going ahead and when you get a chance, downloading Visual Studio 2017 or something like that from DreamSpark now that you have your account.
Oh, okay. Yeah, this is the one that came with the Anaconda.
Yeah. If I knew how to get that up and running, if I knew what to fix, if you feel like Googling and getting that to work, I'd be really interested in your experience. But my way would be just to punt and say, okay, I'm going to go ahead and download the DreamSpark version. So y'all can go ahead and type this in. You're just not going to get the satisfaction of having it run, but that's okay, right? At least you get the memory, muscle memory of having typed all this stuff. Okay, so we're seeing a few things here. We're seeing a variable declaration. In Python, you did not have to declare your variables, right? You could just do name, don't type this. Name is equal to Jeff, and it was ready to rock, right? In this language, and in a whole bunch of other languages, you have to give each variable a data type. You have to tell it in advance what's coming up. It doesn't just pick what it is based on the data that you're storing it in, like Python does. Python knew when I did name is equal to Jeff that, oh, that's a string? Well, I better make a variable called name and make it ready to store a string. Well, that doesn't work in this language. So we can't get away with just doing age is equal to 32 like we could in Python. Instead, we have to give it a data type, like int or float, some kind of numeric data type that can hold a number. So that's why I did that. That's why we have that line. I'm going to add a comment to that effect. in C, all variables must be declared before they can be used. I'm going to put what's known as a multi-line comment by doing a /* and then typing a whole bunch of stuff. Example, int age equals 32, semicolon. Float pi equals 3.14159. Right, something like that. Those are two examples of variable declarations. If we tried to use age without declaring it like that, that would be a syntax error. You can see that it underlined it because it doesn't even know what it is. And if I tried to run it, it would give me some kind of error message. Age is undefined. You'll probably get real used to seeing that error at first. All it means is that we have to go and give it a data type. Now it is defined, and we can use it. All right. And then we have this printf statement. That looks a little bit more complex than our print statements did in Python. But unfortunately, we're just going to have to kind of roll with it. What this is saying is print this string here, and then use this placeholder, and that placeholder is going to get filled in with that piece of data. Let's make another variable, IQ. Int IQ equals, we are incredibly smart, and we have an IQ of 190. So int space IQ equals 190. Now I'm going to make another print statement to print that variable out. Printf parentheses quote, my IQ is, I still need a placeholder. Now what does %d mean? It means a integer type. I wish they used %i for integer. But whoever invented this in 1970, a guy named Dennis Ritchie, decided it needed to be %d. And then a \n. What's that \n? It's just like hitting the enter key. Yeah, it's a new line character. Yep. Okay. And then since I have a placeholder here, I have to put something after the comma to indicate what is going to go into that placeholder. Well, I want that variable IQ to go into it. So comma IQ, end semicolon, end parentheses semicolon. Does your print statement have to have a % sign in it? Not if it's not printing out a variable. Like what if I went to the top of my code here and added a print statement? Printf parentheses quote, this is my first C program. Ignoring the fact that I don't remember if we did one on Monday or not. Now this one doesn't have a %d in it because it's not printing any data. It's just printing the string. Sometimes you'll just want to print a string. Sometimes you're going to want to print some data. Now what if you don't want to print any words, you just want the variable? Like int space x. Now I want to print out x. I'm not going to even say what x is. Printf parentheses quote %d \n. End quote comma x. Now that's not a really good idea because I did not put a value into x. So I'm kind of curious as to what I'm going to see. Right? You ought to put some data into it before you print it out. Otherwise it's like, you know, trying to email a letter before you've typed it. All right. It's giving me an error here, which is a good thing. Uninitialized local variable. Now this is a piddly error. The errors that start with a 4, you can usually kind of ignore. This one, though, this is a warning, but this one actually is serious. I don't think it'll compile with that. So we need to go ahead. I double-clicked on it. I double-clicked on it because I need to fix that, and I'm going to give it a value. What do I want x to be? Well, I don't know. Why don't we give x a value equal to 1, 2, 3, 4, 5, 6, 7, whatever. All right, there we go. This is my first C program. My age is 32. My IQ is 190. 1, 2, 3, 4, 5, 6, 7. Are there other ways of printing data out besides that? Yeah, but we're going to get real used to using Printf. Anybody who's trying to get this to go and who's not using the laptops, they actually have Visual Studio going, getting it to go. Let's delete that close angle right there. Get rid of that one. I don't mind getting that yet, but let's try building it and see if that underline goes away. So go ahead and click on local Windows debugger right there. Good, it went away. Sometimes errors do. But no, we certainly do not want to run it. And as a matter of fact, we don't want it to ever ask us to run it without fixing it. So we have a problem here, and it's my fault. Double click on this thing right here. It tells us where the error is at X is uninitialized, and that's true. So let's go and in front of the semicolon add equals. Just put your favorite number there. Oh, sorry. Should be a free version. But at least it's validating the syntax, right? I bet if you typed in something that was invalid syntax, I might underline it. Okay, so we've seen various parts of the program. We have a preprocessor directive up here at the top. I'm going to put a comment. This is a preprocessor comment. What does preprocessor mean? It means it happens before the code is compiled. The compiler goes and it grabs the contents of this header file and kind of invisibly inserts it right here so that the rest of the program could use it. Without this, I don't think the printf would work. I think if I commented that line out and ran it, it might complain that printf was not defined. Yep, see all this stuff? So we had to have this line before we could start using printf. So we use stdio.h to get printf. That's why we need that library. Now that's different from Python, right, where you could do input and prints and stuff like that without having to use import statements. You did use imports in, in Python in order to bring in libraries, the math library or the random library or this or that, but you didn't have to just to print something. But C is kind of, more low level. It's, kind of roll up your sleeves and do a bunch of work yourself. Now these are called comments. Everything with this begins with a // is a comment. These are single line comments. If you open up, if you do that /*, then everything after that is a comment until you do */. So that's a multi-line comment. Some people get really fancy with their multi-line comments and they make them look like this, right? With cute little stars and stuff like that. You don't have to do that. Then what is this business? We probably remember from Python that you can declare modules. You can declare functions. Well, C++ is the same way, same thing, but not only can you declare a function, you absolutely have to declare a main function, or else the program won't work. Remember in Python, you could just have some lines of code and, it'd be ready to rock. Right? I could type in something and then, click the run button and it would go. Well, C isn't like that. In C, you have to have a main method to tell it where to start running. That is so important, I'm going to go ahead and make a comment to that effect. C and C++ and Java and C# and whatever require a main function. It's like the starting block on a track that you're going to run down. If there's no starting block, you don't know where to start the race. If there's no main method, if there's no main function, sorry, when I use the term method, just think to yourself function. but it's a slightly more sophisticated term that applies to something slightly different. I'll try to use the word function all the time because C itself does not have methods. So this is the entry point. They all require a main function to tell the program where to start. So this is our main function. This is an output statement. This is a declaration. Let's put a comment that this is a declaration. It's also an assignment because we are assigning the value 32 to age. And if you declare and assign a value at the same time, that's called initializing. But you don't have to do that, right? You could declare a variable like this, int ABC, and then you could wait and give it a value later, right? ABC is equal to 32. Right. So this is a declaration right here. We are declaring our variable, we're giving it a data type, and here we're assigning it a value. So every variable you use needs to be both declared and assigned before you actually can try to access it to pull data out. So age had to be declared, which it is right there, and it had to have a value assigned to it, which it's doing right there. And if we were going to print ABC, same thing. Until we do ABC is equal to 32, we better try not to do math to it, right? If I did, age is equal, don't type this because I'm going to delete it. If I did ABC divided by 3, right? That's an error because ABC doesn't have any data in it, right? And it doesn't default to 0. It just flat out doesn't have any data in it. So you always have to have a value assigned to it before you can start doing math like that, or before you can print stuff out. All right, I've talked a lot. I wonder if I've broken my code yet. I'm going to run it. All right, it's still working so far. Go back to the PowerPoint. There's the idea of a global variable versus a local variable. You know what? When this thing says it's for the absolute beginner, I'm not convinced this is for the absolute beginner. But we'll get there. We'll just go slowly. All right, what is a global variable? It's one that's defined outside of a function. And why do you define a global variable? So that it's available to every function inside the C file. This variable right here is only available inside this function. If I wrote another function, I'm just going to give it a silly name, int silly, parentheses in parentheses, and I tried to do something with age, like int I is equal to age, that's not going to work. It underlined age because age is undefined. But I've got it defined right here. Yeah, but you've got it defined between these braces. So it's only accessible inside those braces. Now, to some extent, Python was like that, but to some extent, it was not. And so, if we wanted this age variable to be accessible by both functions, we would have to change its declaration and put it above the functions, which would make it a global variable. I don't feel like doing that. I'd rather just delete this function for now. But I am going to put a comment to the effect that a local variable is defined in a function and is only accessible inside that function. A global variable is defined, can I spell? Outside all functions and is available to all functions. And we'll hit that idea again. It's okay if it doesn't lock in. permanently right now. Now, because this chapter is mentioning it, I'm going to show you how to use the preprocessor to make a number, to make a value, to make a constant. So here's what I'm going to do, is I'm going to do # define, instead of # include, # define, pi, capital Pi, equal 33.14159. Now in this case I don't use a semicolon for reasons I'm not going to explain yet. The reason is that preprocessor commands like that one and that one just don't end in semicolons because they're not part of the language. Right. All of this stuff happens before it tries to get compiled. And by the way, if you're panicking and thinking this seems hard, well, we're seeing it for the first time now, and then we're going to see it again, and then we're going to see it again, and we're going to see it again. Right? If you walked into the classroom, and I've heard that, you know, some classes, like if you try to take French and the teacher speaks French the whole time and never speaks English, I would panic and run out of there. But I'm going to try to make it so that we're not doing it like that. So we see and we hear the French, but then I explain it, and then we brush up against it again, and we brush up against it again. So what is this? Well, now we have something that's equal to pi, so if we wanted to, we could use it, like float area and or diameter. No, I want area because I want to use pi. Tell you what, let's do this. Float radius equals 10. We're going to make a circle with a radius of 10, and now we want to calculate the area. Well, area is pi r squared. So float area equals pi, pi asterisk radius times radius. Why are we getting a grief there? I think I should not have the equal sign here. My mistake. If you're typing along with me still, take out the equal sign from the pi. And now it works. So what we've said is, oh, we have a constant. This is actually what's called a macro. Don't know if you're familiar with the idea of a macro, but a macro is something that gets expanded into something else. Like you might have a macro that says, you know, name, and then when it ran, it might replace everywhere in your document where it had the word name in caps with your actual name, right? It's kind of a shortcut for it. This way I don't have to type in 3.14159 everywhere in my code that I want to use it. I can just use this value instead. All right, now let's print out a message saying that we've calculated the area of a circle. So printf, parentheses, quote, the area of the circle with \n, end quote, close parentheses, semicolon. Printf, parentheses, quote, a radius of %f is %f \n, and I'm going to fill in these two placeholders, these 2% things, with the value of the radius and the area. So after the quote, I'm going to put in radius, comma, area. That should have been a comma. And I'm getting a big underline here, and I don't see why. Oh, because I accidentally put a dot. That's supposed to be a comment. A comma. Okay, there we go. Alrighty, and so it said the area of a circle with a radius of 10 is 314. And that sounds legit. So now we've done some math. Why did that one say %f, whereas these others said %d? Because it's a different data type. These are floating point values, whereas age is a whole number. It's an integer. To print out a floating point value, you have to use %f. To print out an integer value, you use %d. That's important enough that I'm going to add that to my comments up here. You use printf to display on the screen. You use %d placeholder to print integer data. You use %f placeholder to print floating point. And if you mix them up, I'm not sure what happens. So we're always going to get it right. Okay, so now I'm going to make up an assignment for us. Well, I don't want any homework. Well, we're going to do it in class. So here we go. Write a program that, one, sets a height variable to, if we're 6 feet tall, how many inches is that? 72. And then sets a weight variable to, he's a linebacker, he's 300 pounds. And then calculates what's known as the BMI, body mass index, via this equation. Let me make sure I get the equation right. Sorry, I thought I had this memorized, and it turns out I didn't. 703. Turns out I did. Okay. And the equation is BMI equals 703 times the weight, or we could use the fancy word mass if we were physicists, divided by parentheses height times height. That's going to be the equation we use. And then print the BMI. I'm going to change this word body mass index. I'm just going to put BMI and then body mass index. And all body mass index is a measurement, that's supposed to show, proportionately, your weight versus your height. And supposedly, if your body mass index is over a certain value, then you might be considered overweight. And if it's under a certain value, then you might be considered underweight. And on a person-by-person basis, it's not that accurate of a number, because like a weightlifter or a bodybuilder, an athlete will have a higher BMI, and it might even show them as being overweight. But really, that's all muscle, and it's not bad, right? So but for populations, right, if you wanted to find out that all the Samoans are getting unhealthy because they're getting a little bit too large, then over populations, averaging it out, the BMI is used as a statistical measurement. All right, so that's our homework. If we were really awesome, we'd ask them for the height variable. I'm just going to put a comment that that's in inches, and the weight variable is in pounds. So that's my specs. That's my homework. Okay, so what I'm going to do is I'm just going to hit a whole bunch of returns so that it looks like maybe I'll stick this up at the top instead. I almost feel like starting a new program. We've cluttered this one all up, right? But anyways, I mean, we could, but I don't really want us to start it. So let's just do it up at the top. So here's our homework assignment. What's the first thing we need to do? Set a height variable to 72. But I said that every variable has to be declared before you can set it. So we have to give it a type. Well, what if they want to say that they are 72.5 inches? So it can't be an int, it has to be a float. So float height equals 72, semicolon. And I'm going to say that that's in inches, just as a reminder. And then float weight equals 300. And I'm going to put a comment that that's in pounds. Now we need to calculate our BMI. And I remember the equation. It's that. So let's see if I can type that in. Float BMI equals 703 times 300 divided by parentheses. So, wait, why am I using these numbers? We have variables to hold them. So it should be height divided by parentheses weight times weight. That's my formula. If I went back and looked at my notes, hopefully I have that. Yep, that's what I have. And what is this magic number? Well, it's just to convert it to English, and then if you were doing these in metric measurements, it'd be a different number. All right, have we done our homework? Set a height variable, set a weight variable, calculate our BMI. Then we need to print the BMI. I'm going to add a little caveat down here at the bottom. All variables should be declared as float. All right, how do I print? What's my keyword for printing? Printf. So printf, parentheses quote, the calculated BMI is, now I need a placeholder. What kind of placeholder am I going to use for a float? %F. %F. And I'd like for it to go to the next line and not just leave it hanging out, you know, at the, so \n. We could take that out and we'd see what it does. And so after the quote, I need the variable that's going to fill in that %F, which is BMI. And we might want to add some more print statements, right? We might want to print out what the height is and what the weight is. But this meets the requirements for the assignment. And let's stick a pause command in there so that it won't just keep going on. System parentheses quote pause. And that's not going to work for the Mac or Linux users, but yeah, that's all right. I think everybody who's taking the class currently is a Windows user. So, all right. The calculated BMI is 0.56. Now, I actually got that wrong. That is not correct.
I was going to say what you have on the computer, your notes are different.
Yeah, that one, what should that word have been
That
for my
should have been
notes?
white.
Yeah, this should have been weight.
Yeah.
Okay, that's
And
why
then
it turned out
height
wrong.
times height.
See, I did that on purpose, if you believe that. Okay, that one should have been weight. It's still not the number that I'm expecting to see, so I still have an error in my formula. Dadgummit. Weight divided by inches squared times 703.
Oh, the whole thing.
The whole thing.
Oh,
Yeah.
okay, 703. So you want to put 703 parentheses, no, multiplication, let's see.
What am I doing? Why did I change them all to weight?
That first one should say weight.
The first one should be weight. The last two should be height. Okay.
Height times height.
Apparently my mind is not back from lunch. Here we go. That's going to work. The 703 actually was not required, but I like seeing it. Yay, or, okay. So, according to this, that's our BMI. Now, it would be nice if we printed out the height and the weight. We could add 2 extra print statements, but it's not necessary as far as the homework was concerned. Okay, so when you get Visual Studio installed, I do want you to do a little bit of work. Make a project called Homework 1. Add a file called homework1.c. Make it look like this. This is going to be our boilerplate. # include stdio.h int main system parentheses quote pause, right? That's what we started with. And then I'll put a comment here. Leave this out if not on Windows. So that's step 1. That's step 2. That's step 3. Step 4, add code above the system call that does the following steps. A. Creates a variable named temperature in C and puts the value 100 in it. And trivia, 100 degrees Celsius is the boiling point of water. And then calculate the value temp F, which is temperature in F, so this represents Fahrenheit. No, it doesn't. It represents Celsius. Calculate the value temp F, temperature in Fahrenheit. I'm amazed I can spell that. I hope I got it right. By the following formula. And the formula for converting from C to F will be temp F is equal to temp C times 9 times 1.8. What is 9 divided by 5? I think it's 1.8. In parentheses plus 32. That's our formula. But remember, you'll have to put a semicolon at the end of that line. But I'm not going to do it in my assignment. Instructions. And then C, print the value of temp F. Just like we did here. Just like our notes showed us when we were calculating the BMI. Except BMI had 2 values, and this one only was based on 1. And so let's add a comment that all variables should be floats. All variables should be declared as type float. Alrighty. So let's see if we can get this done by next Wednesday. So try to get Visual Studio installed over the weekend. If you never get your email, if you haven't gotten your email by, say, Friday, or even by yesterday, by Thursday, Friday morning, send me a text saying whether you got it or not. Or I can just text y'all and ask, right? You got yours immediately, so it wasn't a big deal. Why don't you check your email? See what's there. Don't look like it. Refresh it just to make sure. I mean, I'm sure it's already refreshed, but okay, fine.
I'll keep checking.
Yeah, check it, and if I'll send a text message out Friday morning to ask y'all, and then I'll contact, the administrator to find out why we're not getting those. Or if y'all want to do the research to figure out how to get your free version of Visual Studio to work, that's also totally cool. I would love for you to tell me. Okay, so that's our homework assignment. I hope it doesn't look scary. If it does look scary, then we can come to class early, right, next Monday, and tell me, and we can spend a few minutes working on it. But let me know. I'll probably be here, but I'd hate for that to be the one day that I waited and showed up exactly on time. All righty, any questions?
Is there a way that we can save these notes?
Some people email them to themselves, some people bring a flash drive. But when you upload the file, it'll be there for you to download later. Okay, so let's go ahead and submit this, but we need to find the C file in order to submit it. And it can become kind of annoying to find it. Let me make the directory first, the folder to put it in. All right, so go to Assignments, Site Canvas. I really wish these didn't line up by date, but oh well. Maybe I'll learn a way to control that. Maybe I'll just learn to live with it. B, first program, I'm going to click on it, and I need to go find my CPP file. Now, if I had been smart, I would have created that in a different place, but I didn't. If I'm curious as to where that is, here's how you find where Visual Studio stored your file, if you're using this version of Visual Studio. You go to the Solution Explorer over here in the corner. If you don't see the Solution Explorer, you do View Solution Explorer. But it's that thing where you right-clicked on it. Right-click on this thing that says Solution and choose Open Folder in File Explorer. And then this tells you the path you're going to need to go to in order to find your CPP file. Right? Users, J.G. Thompson, source, repos, C lecture B. I think I'm just going to copy that path and paste it, right? Because I'm going to need to submit this file. So I'm just copying that path. Now I'm going to go back to my thing where it says Submit Assignment. Submit Assignment. Choose File. I'm going to paste what I just copied into it. Or I could go to the root drive and choose, that same series of stuff. Users, and then my name. And then, all of that stuff. But it was easier for me just to copy and paste it. And then you're looking for the CPP file. If you're not seeing extensions, we need to enable extensions. The way you enable extensions is to go into the View menu, which I don't see right now, so we'll do that in a minute. Go into the C Lecture B subfolder and look for the thing that says C Source. Grab that file and click Open. Then scroll down and click Submit Assignment.